Hi everyone, and welcome to this introduction section on the firepower threat defense. Um, we're going to start this with understanding the difference between a next generation firewall and a traditional firewall. What is new? So if you're already familiar with an L3, L4 firewall, you see what the difference is when you work on a next generation firewall. We'll talk about a brief history of firepower threat defense. We will then look at some of the platforms and models which are currently in the market, and the information and the source where you get that information from. We will also take a look at the different management solutions that are available to you. And finally, some of the deployment scenarios which can help you satisfy some of the use cases. So your organization or your client who you're working for might have a new use case which you have to design for. We will look at what are the options that you have available with an FTD so that you can fit the device as per the use case. NGFW versus firewall. So the major difference of why do you call them next generation, these firewalls, is because of the features, right? It has extensive new features. And most of the times, the major difference would be a traditional firewall generally operates at layer 3, layer 4. So it allows you to block or allow traffic based on TCP, UDP, port numbers, and some advanced parameters. But an NGFW gives you much more, right? It gives you application visibility, intrusion prevention, so you're able to block attacks which may be because of crafted packets. It has ability to read files, do malware protection because it may be able to sandbox files into an environment and then give you a score. And based on that score, you can take a call whether the file which is going through the box is a malware or not. It has security intelligence, which is shared across the globe. Network discovery, it's able to discover an entire network because it keeps a database. It ensures that it knows what is in the network so that it can tune policies or give you a recommended set of rules of what rules apply better to your environment. You can do correlation rules where you can take a couple of events and bind them together and set up custom alerts stating that if this sequence of events happen, then you need a particular set of alerts in your SOC or NOC environment, right? So that's the major difference. A brief history of Sourcefire. It was founded in 2001 as an independent company. It was not a part of Cisco. What it was is they used to provide a commercial version of the Snort software. Snort, as some of you might know, is an open source IPS, network-based IPS. And what Sourcefire provides support on that IPS. Cisco acquired this in 2013 and rebranded this as Firepower suite of products. So eventually they merged the ASA code and the Sourcefire code and created a Firepower threat defense as a firewall, which has the goodness of ASA, the stability of ASA, and on top of it, it gives you intrusion prevention, malware detection capabilities of Sourcefire. Still have Snort available. So for those of you who are interested in writing Snort signatures or even implementing Snort in your network, you still have it available. You can go to Snort's website, download it, and just run it in your network, right? The only difference would be that you would have to write those signatures, you would have to maintain the code, you would have to maintain the signatures of Snort. But what Cisco does is they do it for you. So if, let's say, there is an attack tomorrow and there is a new signature to be written, there is a threat intelligence team called Talos who sits inside Cisco. They're a part of Cisco, and they write these signatures and they give it out to the rest of the world, right? So let's say a ransomware breaks out, these guys will research, find a way to block it, create a signature, share that signature across. So if you have a Sourcefire product, let's say you have a Firepower threat defense product, and you have updates enabled, it'll get updated and you will be protected against that ransomware. So moving on to the next item is FTD platforms and models. So we're going to talk about what are the latest models that are currently existing in the market. We're going to use Cisco's website to do that. And the reason is because the source is going to remain the same. So if you're looking at this video down the line, 2 years down the line, you can go to the same source and maybe a new model might have come up. So to do that, all you have to do is there are other ways to get to this page. I generally do Cisco firewalls and I get here. The other way to do it is you can go to Cisco's parent website, go to products, security, and firewalls, and you'll end up here. right? There is some information about what the firewall does. If you look at this, we have a firepower 1000, 2100, 4100, and a 9300. You can look at each of them. So if you click on them and you look at the data sheet, you will get more details about the throughput that they support, the number of VPNs that they support, number of existing connections, new connections, connections per second that they support, which you can use to then make a call of what is the best for your business, right? We're going to take a look at 9300 because that's the biggest one, the highest throughput support of a box. It's pretty simple if you look at how it all works. So clicking on the data sheet, right? That's the source of truth I generally use. And if you look at it from the back plane, right, it gives you a small overview of what the device is about. It is a supervisor-based device as compared to a simpler box, right? It has three modules which act as three hardware appliances which can be plugged into one supervisor. All the interfaces are present on the supervisor itself, as you can see, right? There are SFP interfaces that you can install here, and then there are network modules which you can plug in to give you more interface capability. Then you can use the data on these sheets to look at what works for you. What is your bandwidth requirement? All of these. So even if you look at these modules, there are multiple types of these modules. There's a 2400, a 30, sorry, a 24, 36, 44, 48, and so forth. And all of them, the difference is the number of CPUs and memory and other hardware chips or components which are placed on these devices, which give you varied amount of throughput and capabilities, right? Software wise, they will run the same software. It is just that the hardware capability that they provide may be different. So if you want a detailed performance specs and highlights, they're also mentioned below. And if you go even further down, you will see ASA performance and capabilities on a 9300. And the reason for this is because the way a firepower appliance is created or architected, you can place multiple software, obviously supported software, on top of those appliances, right? So if you wanted just vanilla ASA, layer 3, layer 4, good protection, you only needed firewalling, but throughput was your requirement, a high throughput with a firewall, then you could use this option. And as you can see, the numbers are pretty high. And you can also cluster them together. It supports a cluster of 16, 16 different modules can be clustered together, working together to provide a much higher throughput, right? Most of the times used in service provider environments. If we go back, there are other deployment options available to you. They have virtual firewalls, which can be used in public clouds or private clouds. Then there is also ASA devices. So if you're familiar with ASA firewalls, or if you own ASA firewalls, physical models, you can convert them into FTDs by re-imaging them. So if you look at the data sheet, if you click on the data sheet and you look deeper, you will get the values and the numbers or performance which you can expect when you do that, right? So that you can make a call of if you want to do that or not. We also have from Cisco, they have Meraki devices. Now these are their small medium business solution, which is it's a pretty good cloud managed solution. We won't be covering that as part of this course because we'll be focusing more on firepower appliances and appliances that run firepower threat defense. Meraki MX doesn't, although they do have intrusion prevention capabilities. They do have support from Talos, but the OS that they run is not the same as FTD. All the other ones that you see here, so they all run Firepower Threat Defense as the software. For our class, we're going to be using the virtual firewalls for private cloud. Because we're going to be using the same software, it can also be installed everywhere else. So whatever you learn here, you can replicate it on any other device as well. There is an exception to certain features. There is a feature called intra-JC clustering, which is specific to 9300. Does not apply to virtual firewalls. There's no point of doing that here. The other exception is SSL decryption. That feature has not been ported to the virtual firewalls, but that feature is anyways not covered as part of this course. We will be covering that separately as part of the advanced course. So taking a quick look at the architecture of the device. So this is, I'm taking a example of 9300, but the others are very similar as well. Let's say this is a 9300 firepower appliance. It has all of the interfaces are present on the appliance itself. And then on top of that appliance, there is a small operating system called FXOS, Firepower Extensible Operating System. It is GUI based and CLI based. And then these are your modules, right? These are still your hardware modules which you plug into the supervisor. And what you can do with the FXOS is you manage all of your hardware, which includes your interfaces, your CPU, your memory, and then it abstracts that out for the software itself. So it's just like a hypervisor, like your VMware, your Hyper-V, or KVM, which manages the hardware and then presents that as components to the software which you can install. So these modules you can very easily install an FTD, or using FXOS, you can take out FTD and install an ASA. It's a very simple process. Obviously, you need to maintain the configuration and you need to migrate that config if you are doing a migration, but installing, reinstalling, reimaging is pretty simple through FXOS. So in case of 4100, it's a simpler box because it's only one module. You still get FXOS because you can manage the interfaces that are downstream. And then FXOS can help you very easily swipe out software. There are many clients, customers who use ASA first. They're comfortable with the ASA. And when they want to swipe out for FTD, they just change the software and they're done. The same concept applies to 2100, Firepower 2100 and Firepower 1000 series boxes. It does not apply to virtual devices because they don't have a hardware. They don't have FXOS to manage. And it also does not apply to 5500 series boxes. They don't have the flexibility to support FXOS. That means you have to reimage that hardware with an FTD like you would do in the old days. So for the next item, we're going to take a look at firepower management, the different models and the different variants which are available to us. To do this, I'm going to follow the same sheet that we were doing before. Like I said, the latest information is always going to be here, so you can always come back and review. So if you look at this, right, just below where we were before, there is a management section of how do you manage these firewalls. Now, there are four options available. Out of these four options, the most robust one is the Firepower Management Center. This was traditionally, or before the acquisition, called Sourcefire Defense Center, which got rebranded as the Firepower Management Center. Now, this FMC, as we call it, is where a feature gets developed first. And then that is the trend, at least until now. And then it gets ported onto a CDO, Cisco Defense Orchestrator, or Device Manager, Firepower Device Manager. The difference is with an FMC, you have one place, a unified place of management for your firewalls. So all of your FTDs could register themselves to the FMC. The FMC then manages the policies, the performance, the faults of all of these devices, right? With an FDM, what you're doing is you're locally managing the device. You're not configuring a manager for that device. So the devices are managed locally. Most of the time, smaller organizations might choose this option because they don't want to have an overhead of another device as a manager. If you have a smaller number of firewalls, which you think is easier to manage on-prem, generally companies or teams or organizations would go for that option. The other one, CDO, is a cloud-based offering. So many organizations like the flexibility of managing policies through a cloud. With CDO, what you do is you give, it's a Cisco cloud, but you get a tenant on that cloud. So you have a localized tenant specifically for your organization. And what you do is you use the cloud to manage all of your devices. And the ease of use here is that you can always, you're on a plane and you want to migrate or you want to configure certain devices or even make rule changes. You can just log into that cloud URL and then you can make changes on the go. SecureX is more of a dashboard. SecureX is not specific to the device, to Firepower devices itself, but it is a SOC dashboard which allows you to do much more than just firewalls. So it provides you a dashboard where you can see feeds coming in from your endpoints. You may have endpoint protection systems which are feeding into SecureX. You have firewalls feeding into SecureX. You have other threat intelligence which is coming in. You have NetFlow devices which are feeding in. So SecureX gives you a threat-centric view of your entire network, and you can make remediation actions through that one pane of glass. What we are going to be focusing on in this course is mostly going to be Firepower Management Center. The reason for that is because it is the most robust. It gives you flexibility with open API support. You can integrate with many tools from SOC. And like I said, at least up until this point, new features do come into FMC first and then they're ported out. So if you learn FMC, to learn others is going to be much simpler because you would know how it works on FMC already. It just, there may be a slight variation of how it is done on the FDM, but the concept of how it works is going to remain the same. And finally, we're going to take a look at the deployment scenarios that are currently supported with FTD. Um, Now with FTD, you get multiple options. You can run it as an IPS IDS mode, which is pure IPS. You're not using it as a firewall. There is a fail to wire net mod that is supported, which is specific to physical devices. And then there is a firewall mode. So in the first one, the IPS IDS mode, what you're doing is you're not using it as a firewall. That means it is not a routing hop. You're using it as an inline mode. What you do in this case is you just bridge the two interfaces together. So from an IPS perspective, whatever comes in from one side goes out of the other side. And then the snot, and when I say snot, I mean the IPS engine will then inspect it for all the anomalies, for malware, and all the advanced features that you have enabled on the box, and then allow it to go. The difference between that and inline tap mode is that in inline tap mode, traffic is still passed through. Traffic is going through the box. Internally, a copy of the traffic is sent to the snot. So snot is there. It is tapping the traffic. So it gives you alert. It won't be able to block anything because it is just receiving traffic, but you get capabilities of detection. Passive mode is slightly different because in passive mode, what you do is your interface is completely in passive mode. So you guide the network to take a copy, mostly done with span or ER span. Take a copy of the traffic in the network and send it to the IPS or IDS device, which then obviously you don't have blocking capabilities here because you're again getting a copy of the traffic, but you're able to see inside and you're able to detect anything inside that traffic. Most of the times in this case, what you do is many deployments that I've seen is you have an SSL decryption device, and many of those devices, what they support is they decrypt inline, but they also send a copy on one interface, which is then sent to an IPS, which could be your FTD. Fail to wire net mod. Fail to wire net mod is a feature capability which is available in hardware models. It is a special type of a net mod, which if you go to Cisco's website, the data sheet that I showed you, if you take a look at the modules that are supported, the network cards, some of the cards support fail to wire. They are a bit expensive than the normal ones, but they give you a capability that if in case, and this is used in scenarios where availability is more important, compared to security. So in those cases, what it can do is, let's say worst case scenario, your firewall restarts, or your snort engine, the engine which processes traffic, or is not able to respond, or restarts. What happens in this case is fail to wire gets enabled. And what it does is it completely bypasses. There is a switch that happens on the module. It completely bypasses the hardware, and it passes the traffic in a way as if the hardware did not exist. So you have availability, traffic still goes uninspected, but you don't lose availability. Coming to the firewall modes, if you're using FTD as an FTD as a firewall, you have two major modes available, and people who have learned ASA before would know about these two modes. We will be doing this in detail, but just as an overview, in routed mode, what you're doing is you might have two separate networks connected to the FTD, and the FTD or the snot engine, it acts as a router, right? It gets traffic, it has a routing table, it makes a routing decision, forwards the traffic, and while it's doing that, it also inspects the traffic. In transparent mode, and it is most likely used in places where you want to place a firewall without disrupting the IP address scheme of that network. Let's say I have these two devices connected on a network of 192.168.2.0, and I wanted to place a firewall. So if I place a routed mode firewall, I would have to change this, right? I would have to give it a different address. I would have to give this interface a different network, this interface a different network, and make it work. But with transparent mode, you don't need to do that. You can just slide in a firewall, which doesn't have a routing table anymore. It just bridges two VLANs together, and those two identities which were connected to the firewall, they don't have to change. They can keep their IP addresses, they can communicate as if they were communicating to each other, but a firewall will be placed in the middle, which is inspecting the traffic across that segment. So that's all from today. In the next class, we'll take a look at traffic flows. What is the life cycle of a packet and what are the checks that it goes through when it's passing through an FTD? We will also take a look at some of the labs. So thank you very much for joining this class, and I'll hope to see you in the next one.